Hi everyone, welcome back to another Planetarium live stream at a slightly different day this week. We apologize for the short notice change, but welcome. Thanks for joining us. My name is Jessica. I am the Planetarium Director, and with me I have one of my students who I will let introduce herself.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
So tonight we are going to be exploring the moons of the solar system. We've done a couple shows where we've gone to the planets and talked a little bit about some of the moons, but tonight we're going to go and explore a lot of the just moons because there's a lot of really interesting ones out there. Some of my favorite things in the solar system to talk about are actually some of these moons. I know, Lindsay, it feels very similar. Now, throughout the show, if you have any questions, feel free to put them in the comments. Lindsay will be watching over those and will let us know when we get any questions coming in. And if we don't get to them right away, we will take time at the end of the show. So with that, I'm going to turn my video off and switch us over to our program. Let's see if this works. All right, awesome. So, tonight we are going to be exploring the moons of our solar system using a program called Celestia. It's a really cool software. It's free to download that lets you explore the universe. And I have the link to it in the description for the video. And so we're starting off here looking at the Earth, because the Earth is actually the first planet in our solar system to have a moon. Mercury and Venus, the two closer planets to the Sun, don't have any moons, so the Earth is the first. And so we're going to venture on over to our moon, and there it is. We can see the side that we are most familiar with that mix of kind of a light and dark gray. Some of it is in nighttime right now, just based on the current phase of the moon. But this is the side that we always see. And turn around to give you a look at the side of the moon that most people don't really know about. Because this side of the moon always faces away from us. So we never actually have this part of the moon facing the Earth. So we don't actually see that for ourselves. We've only been able to do that recently because of spacecraft that have orbited around the moon and gave us our views of that side. So a couple of things with our moon. One of the most noticeable is, of course, the slightly different colors. We have the lighter gray rock and those darker gray rock. That lighter gray rock is known as the lunar highlands, and that's because they sit at a slightly higher elevation. But you can also see that they are covered in craters. Some craters that are still quite bright, that have some streaks where debris was blasted out from when this crater was made, but absolutely covered in craters. And what this is this is the original crust of the moon. And since it doesn't have plate tectonics like we have, it doesn't have water or an atmosphere, so it doesn't have erosion. So all of these craters that have been formed over the past 4.5 billion years stick around. They stay there and they just pile up. And so we end up with this highlands being absolutely covered in these craters. But then we look at these darker areas. These darker areas are known as the lunar maria. Maria is Latin for sea, like an ocean, a body of water. And while these don't have anything to do with water, this name actually comes from before we had telescopes. When people would look up at the moon and they saw these dark patches, they thought it looked like bodies of water. And so they called them the seas on the moon. We now know that they are just rock. They're just a darker colored rock. And when we look in close, we don't see as many craters. They're much smoother than the highlands, in that lighter gray area. And that's because these are ancient lava flows. long ago, when the moon was still pretty young, it was still very hot inside, hot enough for there to be molten rock underneath the surface. And so when we had really big asteroids and objects hit the moon, sometimes it would crack open the surface enough to allow that molten rock to well up to the surface, and then it flooded the surface and pretty much repaved that area and filled in all of the craters that were already there, very much like we fill in potholes in the road. And so that smoothed out that area, and that created these darker splotches. And they're darker in color because it's a different type of rock. This is a basalt, which is a dark lava rock. And I know, Lindsay, this stuff we can find here on the North Shore, is that correct?
Yeah, so that basalt rock comes from magma coming up to the surface. And believe it or not, actually, there used to be a volcano where we are right now, many millions of years ago. And so all of that dark gray rock that you can find on the shores of Lake Superior, that is also basalt. So the same type of lava rock that you can find on the moon.
That's pretty awesome. I just learned that from you a few weeks ago, actually. So that's really awesome. All right. So that is our moon. We know that one pretty well, but now we're going to head on over to our next planet that has moons, which is the planet Mars. So Mars is our red planet because it's red in color due to things like iron that are covering the surface. But Mars actually does have two moons, and you can see them right there. They're Phobos and Deimos. And so we'll go take a nice close-up look at little Phobos, the closest moon to Mars. And you might notice that this looks quite a bit different than our moon. We at the Planetarium lovingly call these lumpy space potatoes because, well, that's pretty much what they look like. They're lumpy, they're not a nice spherical ball, they're covered in craters, and they're very, very small. And so based off of that, we actually think that Phobos and Deimos as well, which I can go show you right now, and looks very similar to Phobos. We believe that these two lumpy space potatoes are actually captured asteroids. So asteroids are chunks of rock that were left behind from the formation of the planets that just didn't go into forming the planets. And a whole bunch of them lie in the asteroid belt, which sits between Mars and Jupiter. So Mars is right next to all sorts of asteroids. And so we think that these two happened to just get a little bit too close to Mars, and Mars's gravity was able to grab onto them and pull them into an orbit around Mars, making them moons. And so that's little Phobos and Deimos, which I think are super cute. Now, Phobos is actually so close to Mars that Mars's gravity is very steadily pulling it inward. And so in about a couple 100 million years, so not that long in astronomy, but Phobos is going to either be ripped apart by Mars's gravity, and Mars will have a nice little ring around it for a little while, or if Phobos, if the rock that it's made of is strong enough to withstand that, it's going to make it all the way down until it crashes onto Mars' surface. So yeah, that's some excitement coming up in a few 100 million years. All right, let's make our way now out to the outer giant planets. And so our next planet that we're heading to is Jupiter. And so Jupiter is the king of the planets, the biggest planet in our solar system. And because Jupiter is so very big and has such a strong gravity, it's able to hold on to a lot of different things. So if I zoom out a little bit here, you can see all of these crisscrossing lines are moons of Jupiter. Current count puts Jupiter at 79 moons, which is kind of crazy. Now, most of these are lumpy space potatoes, like Phobos and Deimos. They're asteroids and comets that got a little bit too close to Jupiter, and Jupiter's gravity was able to grab onto them and create an orbit, create moons out of them, instead of them just flying past and keep on going. But around Jupiter are four larger moons, the four largest of the moons around Jupiter, known as the Galilean moons, because the astronomer Galileo was the first to observe them, so he discovered them. And these are some really interesting moons. And so we're going to start with the innermost of these Galilean moons, which is the moon named Io. And Io, if you saw our kind of teaser posts the other day about the show, you will know that we call this the pizza moon, because it kind of looks like a pizza, right? We got that red sauce, the yellow and white cheese, some black specks that, I don't know, could be sausage or olives, whatever you like. But what's really interesting about Io is every single one of those little black specks that you're seeing is actually a volcano. Io has over 150 active volcanoes, more than anything else in our solar system, including the Earth. It is the most volcanically active object in our solar system. And you know, that's a little strange because Io is smaller than our moon, and our moon doesn't have any active volcanoes. And that's weird because you have to have a lot of heat to keep rock melted and to generate all of these volcanic eruptions. And something really small like Io should have cooled down a long time ago. It shouldn't still be really, really hot inside. And so what it turns out is happening is Io is actually caught in a bit of a tug of war. So we have, let me try and orient so we can see it. There we go. We have Jupiter over there on one side of Io that's pulling Io towards it. And then we have the other moons of Jupiter on the other side that are pulling Io in the opposite direction. And so Io's getting tugged back and forth by all of these things. And as it does that, the rocks inside of Io are rubbing against each other. And just like when you want to warm up your hands on a cold morning and you rub them together to heat them up, that's what's happening inside of Io. As those rocks are getting pulled back and forth and are rubbing against each other, they heat up. And because Io's being tugged on so strongly back and forth, that creates a lot of heat inside of Io, which is what powers all of those volcanoes and makes it so very volcanically active. So yeah, that's our little Io. All right, let's head to the next of the Galilean moons, and this is the moon Europa. So if Io is the moon of volcanoes, Europa is the moon of ice. You can see here that the surface of Europa is covered in ice, and there's some cracks in that ice. Kind of looks like someone's maybe been ice skating back and forth. But what those cracks are showing is that Europa is caught in a very similar tug of war, just like Io is. But it's not as strong, it's not as bad, because Europa is a bit further away from Jupiter. And so that back and forth tug isn't as strong as Io is feeling. And so that causes enough to kind of crack the surface, and it heats up the inside of Europa a little bit. And that means that ice that is sitting underneath the surface of ice is going to get heated up. And when you heat up ice, it melts and you get liquid water. And so we actually think that underneath this icy crust is an ocean of liquid water, and not just a measly little ocean. We actually think that Europa might have twice as much liquid water in its ocean than we have on the entire Earth combined, which is a lot. And this really, really excites astronomers, because one of the things that we think life absolutely has to have to survive is water. And so when we find a place that has a lot of liquid water, that means it could be possible that life formed there. And so we are very interested in exploring that ocean. And NASA and the European Space Agency are working on a future mission to Europa to land on the surface and either drill or melt their way through the ice and drop into that ocean and explore it and search for life. Now, there's a lot that goes into this. Putting aside even the technical challenge of landing on this moon, of melting or drilling through the ice, and creating a vehicle that can explore that ocean, and all of the steps that it takes to get there, we have to be very, very careful to not introduce our own Earth life to Europa, because that could very seriously affect and hurt any life that might be there. And so there's a lot that we have to take into consideration, a lot of prep that has to be done. All right. So next up is Ganymede, the third of the Galilean moons. And Ganymede is also the largest moon in our solar system. Ganymede is so big, it's actually bigger than the planet Mercury, and about 3/4 the size of the planet Mars. It's quite a big moon. And its surface is really interesting. We kind of have a mix of some darker areas and some lighter areas. We see a lot of craters where it's been hit, but there's also some smoother spots. If we kind of look in a little bit closer, we can see that these lighter regions appear to be a little bit smoother. And so what we think we're seeing here are old water flows. So instead of lava flows like we see on Earth, or other terrestrial worlds, what we're seeing here is something called cryovolcanism. And so that's volcanic activity and volcanic flows that use liquid water instead of liquid rock. And that's just because it's so cold out here that you're not going to get liquid rock unless you're very extreme like Io. And so these are old water flows that made their way to the surface and kind of flowed over the surface and repaved the icy surface of Ganymede. And then the last of the Galilean moons is little Callisto. Callisto is not that terribly exciting. Unfortunately, it's just a big ball of a mix of rock and ice, and hasn't had a lot of interesting activity. We really just see a surface that's just marked with lots and lots and lots of craters. But that is the last of our Galilean moons. And so with those finished up, we will make our way to our next planet. And so we're going to head on over to Saturn. So Saturn is most known for its beautiful rings, although it's not the only one to have rings. Jupiter, Saturn, Uranus, and Neptune all have rings. Just Jupiter's are the biggest, or Saturn's are the biggest and brightest. It's also quite a big planet, and we can see as I zoom back out that it also has quite a few moons around it. And it turns out that Saturn actually has more moons than Jupiter. Its current count puts it at 82. So it is the king of the moons of the solar system. Now, just like with Jupiter's, most of Saturn's moons are our little lumpy space potatoes, asteroids and comets that got too close and were captured by Saturn. But Saturn does have a few really interesting ones. And so we're going to start with the largest of Saturn's moons, and that is the moon Titan. So Titan is the second largest moon in the solar system, right behind Ganymede. It's also bigger than Mercury. And it's very unique in terms of moons because it is the only moon in our solar system that has a thick atmosphere. In fact, what you're seeing here are just the cloud tops. The atmosphere on Titan is so thick that we can't peer through those clouds. They block our view. Titan's atmosphere is thicker than Earth's. It's about 1.5 times Earth's. And so it took us a while to be able to peer through those clouds down to the surface. And when we did, we found even more surprises because Titan has liquid on its surface. Now, it's not liquid water because it's far too cold out here for liquid water on the surface. Instead, Titan has lakes and rivers of liquid methane. And it goes through the same sort of precipitation cycles like Earth has with water. It's just, evaporates. You get methane clouds, which then follows methane rain and fill up lakes and rivers of methane. And this intrigues us because while life as we know it needs liquid water, who's to say there couldn't be a form of life that needs liquid methane? And so this is another place that we're really interested in exploring more. We have had one spacecraft land on the surface. That was the Huygens probe that went with the Cassini spacecraft. But we are also going to be sending a new mission, Dragonfly, which is a helicopter because there's an atmosphere, we can fly. And so there's going to be this little helicopter that flies around Titan and gives us more information on what's going on there. So that's going to be really exciting. All right, a few of the other really cool moons around Saturn. We're going to head on over to Enceladus, which looks a bit like Europa. And they're actually very similar moons. Enceladus is another moon that's got this thick icy crust. And underneath that icy crust, we think that there is an ocean of liquid water. Not quite as big of an ocean as Europa's, but still an ocean of liquid water. And you can see that there are some kind of striped cracks down here near the South Pole. And this is actually where a tug of war that Saturn is having with Enceladus, just like we saw with Jupiter and Io and Europa, is causing Enceladus's crust to crack open, and there are actually vents, jets of water vapor that spew out from these cracks, which is how we know for sure that there is definitely liquid water underneath this icy crust, and actually gives us a way of exploring that region without having to melt through, because we can just analyze the water that's sprayed out by the jets. And so that gives us a slightly simpler way of investigating what's going on underneath Enceladus. All right, let's see, what other moon should we do? Should we do Mimas? Let's do Mimas.
Yeah, Mimas is cool.
So we're going to head over to Mimas. This is a tiny little moon, but as we spin around, you can see that there is quite a big crater there on Mimas. And if I oriented this correctly, it might look familiar to you, especially to any Star Wars fans. It bears a striking resemblance to the Death Star, and that's how it got its nickname of the Death Star moon. It turns out that this moon was actually discovered after the first Star Wars movie came out, so it's a complete coincidence that they look alike, but it's always a fun one to talk about. And then I want to show one more. I want to show Iapetus. I like Iapetus. So Iapetus is kind of our two-faced or two-toned moon. You can see that one side of it's kind of this really dark color, and one side of it is a much lighter color. And that intrigued us for a little while until we kind of watched Iapetus as it orbits around Saturn. We saw that it's kind of locked, and it's tidally locked, which means it's like our moon that the same side of Iapetus always faces Saturn. And so that means this darker side is always the leading side as it moves around Saturn. And nearby is another little moon named Phoebe that happens to be this dark color like this side of Iapetus. And so what we think has happened is as things have hit Phoebe, that's blasted out a bunch of dark dust. And Iapetus, as it orbits around Saturn, has started sweeping that up. And because it's always this side that's leading, this is the side where all of that collects. And so you get all of this dark material collected from Phoebe, and then the other side is more of what Iapetus's natural color was. So I've always found that interesting. I love this little guy. All right, so let's head on over to our next planet. Planet with a funny name, Uranus. Now, Uranus has, now I'm going to blank. I think it's 27 moons. We don't have any really big moons like we saw around Jupiter and Saturn. Nothing like the Galilean moons or like Titan. But it does have a few kind of medium-sized moons. And one of them that I want to show you is my particular favorite. And this is the moon Miranda. So Miranda is the smallest of the kind of medium-sized moons. But it's really interesting because it seems to have this really complicated structures on its surface. And you can see right here this kind of feature. And this model's not the best. So we see features like that kind of all over Miranda. And we're not entirely sure what's caused it. It's got this very complicated structure all over its surface, and we're still trying to piece together how all that happened. One of the leading ideas is maybe Miranda is actually a giant rubble pile from a larger moon that got broken apart by a big impact. And as it kind of pulled itself together and pieced itself together, it's made it look like this complicated kind of patchwork. But it's a really intriguing little moon, and I like it. All right. That's about all I have for Uranus. Do you have any you want to talk about, Lindsay?
Is Triton this one, or?
That's Neptune. Yeah. All right, so I will head on over to Neptune.
One cool thing about the moons around Uranus is that they are all named after Shakespearean characters.
Yes, that is true. So we have, I think it's like Miranda, Umbriel, I'm forgetting all of the names, but yeah, they're all Shakespeare characters. And Alexander Pope. I think it's Shakespeare and Alexander Pope. So Neptune also has a similar number of moons as Uranus, but it does have one large moon named Triton, not to be confused with Saturn's Titan. And Triton is strange because when we look at all of the big moons around the other planets, all of those moons orbit in the same direction around the planets. They all orbit, if you were to look down on the North Pole, they all orbit counterclockwise. And that's the same direction that most of the planets spin, and that's the same direction that the planets orbit the sun. This is counterclockwise if we're looking down on the North Pole. But Triton is different. It actually is orbiting Neptune in the opposite direction. And that leads us to believe that Triton has a more interesting history, because all of the other big moons around the planets, or most of the other big moons, I will say ours was an exception, we think formed with the planets in kind of a little mini solar system fashion, that as the planet was forming, these moons were forming around the planet. But because Triton goes in the opposite direction, we actually think it's a captured object, which usually those captured moons are the really small, lumpy space potatoes. But this seems to be a really big captured object. We think that this was something that lives out in the Kuiper Belt. So this is like the asteroid belt. It's just past Neptune, and it's full of icy debris rather than rocky debris like the asteroid belt is. That's where Pluto lives. So Pluto is a Kuiper Belt object. And so we think that Triton started out as a Kuiper Belt object and ended up being captured by Neptune. And so Triton is actually very similar to Pluto and the other Kuiper Belt objects that we've seen, which makes it easier on us trying to study those because this one's closer than the other Kuiper Belt objects. But it's also got some interesting terrain on it. You can see kind of up here this weirdly textured terrain that looks a lot like the skin of a cantaloupe. and that's actually what it's called. It's the cantaloupe terrain. But there's a lot of cool stuff going on there. All right, I think we are about at time, so I'm gonna hop back over to Zoom. We'll check in with Lindsay, see if we have any comments.
No questions or comments.
All right. Well, if you have any, now is a great time to leave them down in the comments, and we will answer those. While we wait to see if there are any questions coming in, a couple of things to remind you guys about or tell you about. So we are currently in the midst of a giveaway to give away this cute little sparkly dinosaur that is just like the one taken up by Crew Dragon to the International Space Station. And so there's the website with information. What we want you to do is draw just a simple little mission patch. It's just a fun picture, and send it to us, and you'll be entered to win. The website link is also in the video description if you'd like that. And we will be randomly drawing 2 winners next Wednesday during our show. So that's super exciting. And then the other thing that's recently come up is we are going to be hosting 2 virtual summer camps. So we have one for recommending for 6 to 8-year-olds, which is our adventure through the solar system. And then recommended for 9 to 12-year-olds, we're going to have exploring alien worlds. And we're going to have more information, including dates and price and registration coming out probably this weekend. At the latest Monday, we will have this information out there, but these camps are going to be run in July. They're going to be lots of fun hands-on activities and also time with Planetarium staff to explore and learn about the universe. And we're really excited to have these. All right. Anything come in?
Nope.
No? All right. Well, thank you everyone so much for joining us on our slightly different night. We will... Okay.
Okay, so from Gwen Walters, how many moons are there in the solar system in total?
That is a good question, and I don't have a specific number. I know it's over 150. Do you have a more specific number, Lindsay?
No, yeah. I mean, there are a lot of moons that we probably haven't even found yet because they're so tiny.
Yes.
It's hard to see them. So, yeah, I mean, it's impossible to know exactly how many at this point.
And then you also have to make the decision of when does it go from being a moon and being a ring particle? Because there are some really big chunks in the rings of these planets.
Yeah.
So, short answer, over 150. Longer answer, we don't quite know, but a lot. Yeah.
A lot.
Anything else?
Nope.
No? All right. Well, one last chance, and we'll tell you what's going on in the next week, and then we'll wrap up. So on Saturday, we are doing a show all about what are called the Messier objects. These are things like nebulae, star clusters, galaxies, things that we can see in the sky that were cataloged by a French astronomer. And so we're going to tell you all about what those objects are and give you some of our recommendations for good ones to try and look for this summer. Some of these can be seen with just your eye if you're in a dark enough space. Some of them do need like a small telescope or binoculars, and we'll have a mix of both in there. Next Wednesday is when we're doing our giveaway. So we're going to be doing our usual beginning of the month show talking about current astronomy news and what you can find in the sky during the month of July. And then we'll also be drawing our 2 winners for our sparkly dinos. And then next Saturday, we are going to take the night off to celebrate the 4th of July. And then we will be back the next week with our regular Wednesday, Saturday shows. So yeah, I guess with
clarify, you don't need special astronomy specific binoculars. Any binoculars that you have from traveling or bird watching or anything, any binoculars will work.
Yes, absolutely. So yeah, that's coming up, all the fun stuff we have going on. Lots to do, lots to see. We hope you enjoyed your show tonight. As always, if you want to catch up on anything you missed, you can find our past streams on our YouTube page or in the videos section of our Facebook page. Camp information is going to be coming out hopefully this weekend. We're so excited. They're going to be so much fun. We've been working really hard on these. I'm very excited. So yeah, thanks for joining us. We hope you have a great rest of your evening and hope to see you again. So thank you and bye everyone.